Have you do any kind of analysis on runtime optimizations like Java Virtual Machines does or wherever, you know? There's a lot of optimizations like automatic inline, and rule lobs, everything that Java Virtual Machine does, and it's really amazing. Have you studied something of this?
I didn't quite understand the question. Have I done it with Java? Was that the question?
If you have to do some analysis of the Java Virtual Machine optimizations, that is doing all of this, but in line. You know, they are doing on the runtime.
Oh, if the argument is calculated at runtime instead of the constants, you mean?
Yep.
Yeah, well, then the compiler has to do the actual code to add, but I just did the constants to show you that no matter how you do the constants, the compiler always does not have to generate any adds. But if it's runtime generated, the values, then yes, the compiler will have to actually do the add.
There was another question. Who was it?
Why did you pick optimization at the topic? Because in most cases, I think people have more problems writing correct code, and it doesn't matter to optimize when your code still contains many bugs.
Yeah, that's right, but I think it goes hand in hand because in most cases the bugs come from people trying to be more clever than they should be. And I'm saying don't try to be more clever than your compiler because usually you aren't. And if you don't do self-balancing red-black tree crap to sort 10 elements but just use qsort and an array, then you will have less bugs. So, yes.
So my question is, when the compiler generates 64-bit code, is that really faster than 32-bit code?
Well, that depends on what you're doing with it. So, for example, if you do big number arithmetic, then it's a lot faster because you get more done per calculation. But if you do something else like graphics code, then there might be a benefit or there might not be a benefit. But if you ask on x86 versus x64, then x64 has more registers, so it can do more. The compiler has more optimization opportunities, and I chose to use 64-bit code here in many cases because the code is easier to read. It's less code. You need less code for the same stuff, so I'm using 64-bit all the time.
Did you use any compiler optimization options?
In my examples, you mean?
Yes.
Oh yes, I always use like -02 or -fast on Intel. I use like the usual. I don't use any special stuff like -f whatever, but I use -02 or -os depending on if I compile stuff for myself. I use os, which is like 02, but leaves out the optimizations that cause more code to be generated, because that's usually bad because it uses up more cache memory. But in these examples, I usually use -02 and -f omit frame pointer. But no special magic stuff you couldn't try at home. So I think that's it. Thank you for coming.
There would be.
Oh, there's one last. Okay.
We've got a quarter of an hour left, so there's actually some time for questions.
In university, you learn a lot about sophisticated data structures like red-black trees and AVL trees, and they really suck. But do you say they should be omitted at all, or as a rule of thumb, when should sophisticated data structures be used, and when should you stick to easier data structures?
I'm saying if you have reason to believe that your code will be used on huge data sets, then by all means use good data structures. But if you use, like, for example, the STL standard string in C++, that actually uses a red-black tree of string fragments. And that's why if you have a small string and just concatenate another string, you will have like 100K of code. That really does nothing. And you just have like 20 characters in your string. Right? So in many cases, people just use overblown data structures and don't get any benefit from it, just get the downsides. So yeah, you should learn about them so you know them when you see them, but be very careful before using them.
I was reading some kernel code recently, Linux kernel code, and I saw that they use GCC extensions like the likely and unlikely definitions in if conditions.
That's actually part of C99. So this is
okay. I never saw that in userland code, so I wanted to ask if that really gains you something, or if that's just like.
So these likely and unlikely statements, in case you don't know them, you can, for example, if you say if, and you have like a range check, and you can know that in most cases the range check will not be triggered because most of your code does the correct ranges. Then you can say if unlikely, and then the actual condition. And the compiler, you can tell the compiler with this that this jump is less likely to be taken. And the compiler can arrange the code so that the path that is usually taken is straight, in a straight sequence in memory. So this does gain you something, but only in a few places. And there is userland code using it. For example, glibc uses it, and mysmall-libc also uses it. But in most cases, it doesn't gain much. But it's a habit. You should do it if you can. The problem is that most programmers are notoriously unable to predict how their code is being used and which is actually faster and what should be taken and what not. So it's usually easier to use profile-guided optimization in the compiler than trying to guess which one is likely and which is not. But in clear cases like range checks, yes, you should use those.
Do you actually have anything to say on the restricted keyword, or have you ever seen it actually do anything? Because I've tried like retrofitting code with restrict, and it didn't do nothing for me. And GCC, of course. So.
Well, the C standard doesn't actually say you have to generate different code. It just says it's a keyword. So I think what they did first is just recognize the keyword and then do anything with it. But you can construct functions where it matters. So for example, this foo function, where was it? Crap, what the hell? I have too many functions. Okay, I'm not finding it. The aliasing example, where was it? What the hell? Okay, you can look it up yourself. But so you can construct examples where it actually makes a difference, because the compiler suddenly does use the sub-expression elimination. So it does make sense, but usually it doesn't. You should still use it because later versions of the compiler might be slow, might be more intelligent, and you wouldn't want to go over all your code again if the compiler finally starts to really do something. So yeah, I recommend using it. Sorry. Okay, thanks for your time. I hope you learned something.